Today we're solving equations that contain rational expressions. Solving is a key word here. It says solve for x. This means I'm going to get x equals something. Solve. X equals something. Up until this point, we've been simplifying or combining or manipulating rational expressions. Now we're solving equations. And one way to know is because it says solve. The other way to tell is that it has an equal sign with things on both sides. Okay? And then I know I can solve for the variable. Up until now, we've been unable to solve for the variable. I start this the same way I start any addition of rational expressions. There are multiple ways to do this, but all of them start with factoring the denominators. So I can find my least common denominator. So I'm going to make one here look like it's a fraction. That way I have everything as fractions and I can factor my denominators. This will give me 2x minus 2. 4 times x minus 2. And this, of course, is 1. I like to have it on my paper for reference, the least common denominator. I have 2 times x minus 2. I have 4. 4 is 2 times 2, so I have to multiply another 2 up here in my least common denominator. X minus 2 is covered with this x minus 2, and 1, of course, is just 1. So my least common denominator is 4 times x minus 2. I can build each fraction to the least common denominator. So to do that, I'm going to multiply 5 over 2 times x minus 2 by 2 over 2. My 4 times x minus 2 is my whole least common denominator, so I don't have to multiply x plus 2 by anything. Over here, I'm on this side of the equation, I'm going to multiply by 4 times x minus 2 over 4 times x minus 2. Now, I have 10 plus x plus 2 all over 4x minus 2 equals 4 times x minus 2 over 4 times x minus 2. What happens when I multiply everything by my least common denominator? I'm just going to group these together. I haven't combined terms yet. And I'm going to multiply both sides of the equation by 4 times x minus 2. I can do that because I have an equation. I cannot do this when I've been combining expressions because I don't have an equation. However, when I have an equation, if I multiply both sides of the equation by the exact same thing, I don't change the equality of the equation. The equation is still balanced. So I can multiply this side by 4x minus 2 over 1. I can multiply this side by 4x minus 2 over 1. And now I can simplify each side as long as these are factors. This here hasn't been simplified, but because I have it in these brackets, it's contained as 1 unit. And because it's 1 unit, it's multiplied by this 4 times x minus 2. So I can divide out both the 4 and the x minus 2. To leave me 10 plus x plus 2, what was in that bracket. Same thing here, I can divide out 4 with a 4, and x minus 2 with the x minus 2, and that's going to give me 4 times x minus 2. Now I'm going to distribute and combine like terms. This will give me 12 plus x equals 4x minus 8. I'm going to move my x's to one side, everything else to the other side. So I'm going to add 8 to both sides, and I'm going to subtract x from both sides. This will give me 20 equals 3x. I divide both sides by 3, and I get x equals 20 over 3. There's one last thing I have to do when I'm manipulating, when I'm multiplying by variables on each side of the equation. If I have a variable in the denominator, and I do way up here in my original equations, I have to make sure I haven't multiplied by something that makes me divide by 0. So I have to check my x equals 20/3 and make sure up here that if x is 20/3, I'm not dividing by 0. No, that still gives me a real number. It's going to, this still gives me a number other than 0. And this was 1 to begin with, so I'm fine there. So my solution is a real, an existing solution, and it is x equals 20 over 3.